Hello once again. You're still with Teacher King David, and we are still on revision questions. So let's go to number 6. Number 6 is saying that determine the modulus and argument of 1 plus I power n and 1 minus I power n, where n is a member of natural numbers. So this number 6a and b, it is from number 9 Reb 2007. That's where you can find it. Okay, let us start with number 6a. We're going to find the modulus and argument of 1 plus I power n. So how can you find the modulus for this and the argument of that one? Remember, when you have a z equal to a plus bi, you can express this one into polar form, where z will be equal to r into bracket cos angle plus I sine angle. So where r is the modulus of z, r is the modulus of what? Of z. So this r is the modulus of z. How do we find the modulus of z? Is the square root of a squared plus b squared. So then, what is z power n? Z power n is a plus b power n, a plus bi power n. So now, if it is a plus bi power n, we check, because we have converted z in polar form, so now z power n, by using the Mover theorem, it becomes r power n into bracket cos n angle plus I sine n angle. So by using the Mover theorem, that's what? Z power n. So what does it mean? You're going to let this one, we'll let z be 1 plus I. So what do we need? We need to get r, which is the modulus, and we need to get the argument, because this angle is the argument of z. So we need to find the argument of this z and the modulus. So from this formula, our r, which is the modulus of z, will be equal to the square root of a squared, that is 1 squared. Coefficient of I, it is 1 squared. So finally r is root 2. So that's the modulus of z, only z. Then what is tan alpha equal to b over a? So alpha is tan inverse of b over a. So which means that alpha will be tan inverse of, our b is 1, our a is 1. Tan inverse of 1 over 1. So alpha is, tan inverse of 1 is pi over 4. Pi divided by 4. So then we use quadrants to know the location of that angle, of that complex number. So our a is positive in positive x-axis, and our b is positive in positive y-axis. So they meet in the first quadrant. In the first quadrant. So, and you know that in the first quadrant, when you're in the first quadrant, angle equal to alpha. So our angle will be pi over what? Over 4. That is our angle. So now, so what will be 1 plus z power n? What will be z power n? Which is 1 plus I power n. So z power n, by using the Mover theorem, which is this formula, it will be z power n, it will be equal to r power n, and our r is root 2. That is root 2 into bracket power n cos n angle, our angle is pi over 4, plus I sine n angle, our angle is pi over 4. So you know that square root of 2 is 2 power half. So this is 2 power half into bracket power n, bracket cos n pi over 4 plus I sine n pi over 4. Then, you know when you have like a power n power m, the answer is a power nm. I think you remember this. So which means that 1 plus I power n, the answer is 2 power n over 2 into bracket cos n pi over 4 plus I sine n pi over 4. So what does it mean? It means that the modulus of this, the modulus of 1 plus I power n is 2 power n over 2. And the argument of 1 plus I power n is n pi divided by 4. That's the answer. So now we have done part 1, which is the question was to find the modulus of 1 plus I power n and the argument of 1 plus I power n. So we're going to find the modulus of 1 minus I power n and the argument of this one. So now for 1 minus I power n, so still let's say that z equal to 1 minus I. Then we find its modulus and the argument of that one. So the modulus of z is square root of 1 squared plus negative 1 squared. So finally, the modulus of this z, that we can call it r, is root 2. So our r equal to what? To root 2. So from there, what is the argument? Tan alpha always equal to b over a. So tan alpha will be equal to, our b is 1, a equal to 1, even b equal to 1. I told you that we don't consider negative. We consider negative when we are checking for quadrants. So tan alpha is 1 over 1. Tan alpha will be equal to 1. Alpha is tan inverse of 1. So now alpha will be pi over 4, because tan inverse of 1 is pi over 4. So after getting tan alpha, so we're going to see which quadrant that we can find that z equal to 1 minus I. So this is A, which is on x-axis. It is positive. But B, here we have negative, which is on y-axis, negative. So here it is in the fourth quadrant. Fourth quadrant. And in the fourth quadrant, angle equal to negative alpha. So which means that our argument will be equal to negative pi over 4. That is our angle. So now we can express this z in the polar form, where we say that z equal to r into bracket cos angle plus I sine angle. So z will be equal to root 2 into bracket cos pi over 4 plus I sine pi over 4. So this is our polar form. So after that, what will be z power n? What will be z power n? Z power n will be equal to r power n into bracket cos n angle plus I sine n angle. By using what? By using the Moivre theorem. So now, 1 minus I power n, the answer is root 2 power n into bracket cos n pi over 4 plus I sine n pi over 4. So meaning that it is root 2, I told you that root 2, it is 2 power half, which is 2 power n over 2 into bracket cos n pi over 4 plus I sine n pi over 4. So what does it mean? It means the modulus of 1 minus I power n is 2 power n over 2. So then what is the argument? The argument of 1 minus I power n, the answer is, this is minus. This is supposed to be minus. This angle, it has a minus. It is minus pi over 4. Even here it is minus. We have also minus here. So here it will be minus, even here. So which means that our angle is negative pi over 4, because our angle here is negative, which means that 1 minus I power n is 2 power n over 2 into bracket cos negative n pi over 4 plus I sine negative n pi over 4. Because our angle is negative. So which means that our argument of 1 minus I power n is negative pi over 4, negative n pi over 4. So here it is n into bracket negative pi over 4 plus I n into bracket negative pi over 4. So then here it will be minus here. This is minus. You know that cos of a negative angle is the same as cos of that angle. Sine of a negative angle equal to minus sine of that angle. It is minus sine of that angle. Sine of negative angle equal to minus sine angle. So that is why cos of negative, it is cos of that angle. Sine of negative, it is minus sine of that angle. So finally, our argument is negative n pi over 4. So that is the answer for finding the modulus of 1 minus I power n, which is 2 power n over 2, and its argument is negative n pi over 4. So now we're going to do number B, number 6b. We're going to use 1 plus I power n plus 1 minus I power n. Then after, we'll do 1 plus I power n minus 1 minus I power n. So remember, we got that 1 plus I, if you remember, 1 plus I power n, we got that it is 2 power n over 2 into bracket cos n pi over 4 plus I sine n pi over 4. So and we got that 1 minus I power n is 2 power n over 2 into bracket cos n negative n pi over 4 plus I sine negative n pi over 4. Which is the same as 2 power n over 2 into bracket cos n pi over 4 minus I sine n pi over 4. Because I told you cos of a negative angle is the same as cos of that angle, sine of a negative angle is negative sine angle. I hope you still remember that one. So that's why instead of negative n pi over 4, now we have cos n pi over 4. Instead of sine negative pi over 4, now we have minus I sine n pi over 4. So now we're going to add this. We're going to add this with this one. So finally, 1 plus I power n plus 1 minus I power n. What is that? We just take this plus this. So that is 2 power n over 2 into bracket cos n pi over 4 plus I sine n pi over 4 into bracket plus 2 power n over 2 into bracket cos n pi over 4 minus I sine n pi over 4. You see, we have the common value, which is 2 power n over 2. We take it out of the bracket. We remain with this cos n pi over 4 plus that one plus I sine n pi over 4 plus cos n pi over 4 minus I sine n pi over 4. We close the bracket. You see, cos n pi over 4 plus cos n pi over 4. Those are 2. So this is 2 power n over 2 into bracket 2 cos n pi over 4. Then I sin n pi over 4 plus I sin n pi over 4, we get 0. So remember, when you have addition of complex numbers, we add real part together and we add imaginary part together. So the real part is cos n pi over 4 and cos n pi over 4. We have 2 cos n pi over 4. The imaginary part is I sin n pi over 4 and negative I sin n pi over 4. They are the same with different signs. So this minus this, that is 0. So just remain with 2 cos n pi over 4.